Hello, welcome to the science lesson, which is on gas pressure. By the end of this lesson, I want you to be able to describe how the particles in a gas move and describe the relationship between the temperature and pressure of a gas and explain Brownian motion in terms of particles behavior and collision. So as a starter work, I want you to make a mind map of pressure based on your prior knowledge. What do you think the pressure is? And the extension work is, what does random mean? Can you give some examples of random events? So you can pause the video and you can draw your mind map, and then you can write whatever you think a pressure is. All right. So I will show you my mind map after this lesson, at the end of this lesson, so that we will be able to connect the link between the gas pressure and today's lesson. So according to our bigger picture, this is the last lesson of P6, which is molecules and matter, and the title of this lesson is gas pressure and temperature. So that's your prior knowledge. We have been going through this kinetic theory of gases from lesson 1 till 5, and just a quick review. The kinetic theory of gases states that the gas consisting of very small particles, each of which has a mass or weight in SI units. Molecules are in constant and random motion. Particles constantly collide with each other and with the walls of the container. There is a little attraction between the molecules and only exert force on one another when they collide. So when we talk about a tin of beans or any kind of tin, why we should not heat a tin of beans? So the answer is in this video. If you play this video and you come up with your answer, you can relate this to the gas pressure. So what happened when the gas is enclosed into the container? The particles that are free to move randomly bounce off each other and the sides of the wall, causing pressure. So when you increase the temperature, you can increase the movement of the particles. They are moving vigorously and they are hitting the walls of the container, and that can increase the pressure on the container, and it can blast, it can have a led to the fire and all that, as you have seen in the video. So basically, by increasing the temperature, you can increase the movement of the particle, which can increase the pressure due to the increase in force. Okay, so you can pause this video and you can write down the description of the movement of the particles in a gas and describe how the gas produces pressure inside the container, and explain what happened to the gas particles when you do heat. So you can pause this video and then come up with your answers. Okay, welcome back. And the ideal answer is here. As gas particles move about at high speed due to increase in temperature, they bang into each other on whatever else happened to get in the way. So faster particles and more frequent collisions both lead to an increase in the net force, and so gas pressure. So increasing temperature will increase the speed and so the pressure. So if you keep the volume constant, then the temperature and pressures are directly proportional to each other. By increasing the temperature, you will get the higher pressure. Alternatively, if you keep the temperature constant and you increase the volume of a gas, it means that the particles get more spread out. They have more space to move on. So they hit the walls of the container less often. They have less chances of collision. So due to less chances of collision, the gas pressure decreases. So we conclude that pressure and volume are inversely proportional. When volume goes up, so pressure goes down, and vice versa. If you increase the volume, then pressure decreases. If you decrease the volume, pressure increases. And the mathematical relationship is here. PV equals constant, where P represent the pressures and the unit of pressure is Pascal. V represent the volume and the unit for volume is cubic meter. So you can watch this video and can you explain this? What's happening? There is a change of shape due to increase or decrease the pressure, internal pressure or external pressure. So watch this video and come up with your answer and then we will discuss. Right. So as we said, a change in pressure can cause change in volume. So how this happens? The pressure of a gas a net outward force at right angle to the surface of its container. So there is also a force on the outside of the container due to the pressure of gas or pressure of air or atmospheric pressure around it. So for example, when we talk about the helium balloon, when helium balloon is released, it rises. And we know that the helium is a lighter gas as compared to the atmosphere, so it rises up. So atmospheric pressure decreases with height. This is a factor as well. So the pressure outside the balloon decreases. This causes the balloon to expand because inside pressure and outside pressure is not equal. So this causes the balloon to expand until the pressure inside the balloon drops to the same as the atmospheric pressure. So due to this, when you change the pressure outside or inside the container or the balloon, then the volume, the size of the things has been changed as well. Based on this information, this is an interesting fact and a real life example. So when you take a pack of crisp to the top of the mountain, the pack of crisp expand. And the reason behind it, the same, the balance inside and outside pressure balancing. So you can explain this interesting real life example based on the information of the last slide. Okay, Brownian motion, it is very interesting. So Robert Brown, he discovered the cell nucleus when looking at cells from orchids under his microscope. In 1827, the biologist Robert Brown noticed that if you looked at pollen grain in water through a microscope, the pollen jiggles about, and he called this jiggling movement as a Brownian motion, but he couldn't work out what was causing it. So here is a video. If you play the video and then you can see the smoke particles under the microscope and they are moving and they are jiggling about. So this is again the movement of the particles which hits the smoke particles right and left. So this is the evidence of the random movement of the particles inside the container. Okay, so this was our initial slide, what we have think on your prior knowledge, what you already remember from Key Stage 3 about pressure. This is my mind map and the facts about the pressure. So pressure is force per unit area. All the particles exerting force wherever they are hitting or they are moving. So whatever force they are exerting on the particular area, this is called pressure. Pressure decreases with the increase in height. As you go up, 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 up high in the mountain, the pressure decreases. Pressure increases with depth. So if you go down into the sea, as you go down, down, deep into the sea, the pressure increases with depth. As we have seen, the pressure and volume are inversely proportional to each other, or you can say pressure and temperature are directly proportional to each other. That's the relationship between pressure, volume, and temperature. Related to extension question, random mean, like there is no sequence. This is just a frequent collision, so it can be happen the random movement of the particles, like you can't predict where they are going to hit and at what force they are going to hit. So it depends on their movement, on their frequent collision and all that, and it's all random. You can't predict it where they are going to be. Right, so this is as a plenary question, this is your learning pyramid. I want you to write down one question what you don't still understand based on this lesson, and I want you to go through and search into about your question. Second, I want you to write down what you have learned new for the first time in this lesson. And the third thing, I want you to write down what you already knew about it. What was your prior knowledge based on that? You can pause this video and then you can do your learning pyramid. As a last question, this is the exam question, and in this question, you will be assessed on using good English, organizing information clearly, and using specialist terms where appropriate. You can see this is a 6-mark exam question, and the information is based around solid and gases. So you can divide these 6 marks around 3 marks around solids, 3 marks around gases, and then you have to answer the spacing between the particles in terms of movement of the individual particles and movement, the force between the particles. So you can pause this video and you can do this 6-marker exam question, and then you can mark your answer on the next slide. Right, here is the answer of that 6-marker exam question. Make sure like you write down this in paragraph with clear information and with good connectives. All right, so thank you very much. I hope you have learned in this lesson. Thank you.